Our topic today is tangents. And we talked about tangents a little bit when we were doing the parts of the circle at the beginning of this unit. But a tangent is a tangent line intersects a circle at exactly one point, and that's called the point of tangency. So how do we know if when a line intersects at one point on that circle, how do we know if it is a tangent line? Well, we know it's tangent if it's perpendicular in the way it intersects it. So a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So here we have our tangent line, the radius coming from the center of our circle, and this is going to be a right angle right here. So now if we know we have right angles, we know more than likely we're probably going to be able to use the Pythagorean theorem. So let's look at number one. This first one says determine if AB is tangent to circle P. So here we're going to look at our tangent line and we want to determine if it is actually tangent. Well, it's going to be tangent if this is a right angle. And so I'm not going to draw the right angle in there because I don't know if it is, but that's where it should be. That right angle should be at the point where this tangent line is meeting the radius out here on the edge of the circle. Our right angles are not here and they're not here. So we want to utilize our Pythagorean theorem. So we see this would be our hypotenuse. So that means these two sides are going to be our a squared plus b squared set equal to c squared. So if 8 squared plus 15 squared is equal to 17 squared, then that's a right angle. If these two do not add up to 17 squared, then that's not a right angle. So in this case, they do equal each other. So if 289 is equal to 289, then yes, this is a right angle, which means that this line here, AB, is tangent. Okay, now the other thing that we're going to see in these types of problems is that a radius here is 11. I see this line over here, and I don't have a value for this. But I do know that this is also a radius. So this value here is going to be 11, just like this one is. And so now I'm looking at, is AB tangent to the circle? So now I'm back to determining if this right here is a right angle. So I use my Pythagorean theorem again. This time my hypotenuse out here is 16. That would be the entire thing. Adding 11 plus 5. So we're going to take our 11 squared plus 14 squared, which are our two sides, and we're going to set it equal to 16 squared. If this is true, then this would be a right angle right here. But when you calculate this, you'll find that this is actually 317, and this is 256, which means that they do not equal each other, which means then that no, that's not a tangent line. Okay. For the next set of problems here, it says if JK is tangent to circle L, find X. So now we're going to say we want JK to be, I'm going to do number 4. I want JK to be tangent, so I'm going to find that my right angle is going to be right here where the tangent and that radius intersect at that one point on that circle. And so now I want to determine what is this side length going to be for this to be a right angle or a right triangle. So I am going to say x squared plus 11 squared is equal to, now here I have a 7 right here, and I have this 11 is the radius, so I know this is going to be an 11 as well. So that means that this entire hypotenuse has to be 18, and so this is going to be set equal to 18 squared. Then I just want to solve for x. So x squared plus 121 is equal to 324. You're going to subtract that 121 from both sides. X squared is equal to 203, and then remember you want to take the square root of both sides, and x is going to be equal to 14.2, and that's my answer. So if x is 14.2, then this will be a tangent line because this is a right angle and this becomes a right triangle. Okay, I would like for you just to practice these on your own. So go ahead and do 3, 5, 6, 7, and 8, and then on the back side, do 9. Pause the video, and then we'll move on after you finish those. Right, so here are the answers. 3 was pretty straightforward as far as just solving for that x squared there. For number 5, we had a radius of 10, and so we needed to put that 10 in right there. I'm going to go ahead and work out number 5. Here we had a radius of 10, and so we know that this is also 10. But when we're setting up the Pythagorean theorem here, we're going to see we want 10 squared plus 24 squared to be equal to, and now the hypotenuse is what we're looking for, but we've got an x that we don't know, but we also know that this is 10. So an easy way to do this is just choose another variable and call the whole hypotenuse y and set this equal to y squared. So if we can figure out what the entire thing is, then once we know what x is, or once we know what the entire thing is, we can just subtract 10 and get what the x is. All right, so what this looks like is this setup, and then from here, when we square those and add them together, we get 676 is equal to y squared. Take the square root of both sides. Y is equal to 26. So now that I know that this entire side is 26, then I can figure out that x is going to be equal to 26 minus 10. Okay, and so our answer here is 16. Okay, for the other ones here, 6 and 7, hopefully you recognize that the radius here was 11. This is also a radius, so that's 11. And so you add those two together to get 22 for that side. Here, same thing, they gave us 3.5, and so we can double it to get the entire side of 7. And number 8 is very similar to number 5, except instead of solving for the hypotenuse, we're solving for one of the sides. So we just call this entire side y, solve for y, figure out that this whole thing needs to be 24, and then if this whole thing is 24 and that's the diameter, then half of 24 is going to be 12. So all they're asking for is just x right here, and that ends up being 12. Number 9 I wanted to do with you. So here we have x, and then our other side length is going to be 20. Remember, our 90-degree angle is going to go there. So the 10 is actually x here is the radius, 10 is this, so x plus 10 is going to be my hypotenuse, and this is the side 20, and that's the side x. All right, so we set up our Pythagorean theorem, so we have x squared plus 20 squared is equal to, now here we're going to have to just go ahead and say x plus 10 squared. And now we are going to remember some of our algebra skills. So x squared plus 20 squared is equal to, remember this is a binomial that we're squaring, we don't just square the x and square the 10, we are actually taking x plus 10 times x plus 10. Then we need to do our FOIL. So for this we're going to take x times x, so that becomes x squared, that's the f, the o, the outside we're going to do plus 10x, the inside plus 10x, and the outside, which is 100. We used FOIL. And we set that equal to x squared plus 20 squared is 400. All right, so now we want to go ahead and just simplify. So if I subtract an x squared from both sides, I'm going to end up with 400 on this side. And then over here I want to combine my like terms, so this becomes 20x plus 100. I'm going to run out of room. So now what we do is we subtract a 100 from both sides, so we get 300 is equal to 20x, and then just solve for x. So x is equal to 15, and that's our answer because of the way we set this up. We're just really needing to look for x. Okay, we have another little section to these notes, more about tangent lines and their properties. If two segments from the same external point, so B is our external point here, are tangent to a circle, so this is tangent here, that's tangent there, then they are congruent. Okay, so AB here is going to be congruent to CB. The other property is that if a polygon is circumscribed, so the polygon here is going to be our triangle. Remember, we're dealing with polygons. We had that whole unit on polygons. We worked mainly with quadrilaterals, but poly could have any amount of sides there, 3 or more. So our polygon circumscribed means we're on the outside. Inscribed would be on the inside. So circumscribed is around it. If you have that, then all sides are tangent. Okay, so BC is tangent here, AC is, and so is DB. All right, so let's look at number 10. Find each value or measure. Assume that segments appear to be tangent are tangent. So here they're telling us these are tangent. So we see that these two are going to be congruent. So we just say 5x plus 23 is equal to 8x minus 19. And we would just solve for x here and find that x is equal to 14. Same thing on this one. You can go ahead and work that out. Be careful, at the end they ask you to find PQ, so take your x, plug it back in. Okay, this problem we're going to have to do a little bit more work. So these two lines are tangent, so I'm going to put my right angle here. I want to find SV, which is this. So I'm just going to use the only thing I have here that I can use at this point, and that's that these two are going to be congruent. So I'm going to set 10x minus 41 equal to 4x plus 7. I solve for x, and x is equal to 8. So now I'm going to plug this 8 back in to figure out what ST is. So ST is equal to 10 times 8 minus 41. That ends up being 39. So now I know this value here is 39. Okay, so now that I know that this is 39 and I know that that's 17, I'm back to doing what we did on the last, the first problems here, and we're going to use the Pythagorean theorem to say that 17 squared plus 39 squared is equal to, and then let's just call the hypotenuse here y so we don't get confused with our x's. So 17 squared plus 39 squared is equal to y squared. Okay, so you get 1,810 is equal to y squared. Divide both sides by y, and so y is going to be equal to 42.5. And this y actually does represent the SV, which is what we're trying to find. So SV is equal to 42.5. Okay, and then these last two problems are dealing with the circumscribed polygon around the circle, and these are all tangent. So here we know that if these two lines are both tangent, this is a situation like what we had up here. If this is 11, then this will also be 11. And if this is 16, then this is 16. And if this is 9.5, then that's 9.5. So to find the perimeter, we're going to add up around. So you just add up 11 plus 16 plus 16 plus 9.5 plus 9.5. Can't remember if I said the 11 first there. And add up around, and your answer should be the perimeter is equal to 73. So why don't you go ahead and try this number 14 and pause the video. All right, here's the answer to number 14. You end up finding some of these little pieces that are congruent, and then they're also giving you the total on some of them. So if you know that what one of them is, you just subtract to find the other one, and then you've got congruency. So you should have gotten 180 for that one. All right, so that's it for tangents.